So last week last time we know the variable, there's some constant, sometimes the variable may have some value we can control, but sometimes the variable value we cannot control, so which is called the random number. There are different kind of the variables. Basically depend on the values. It can be classified as quantitative and qualitative. For the quantitative, it can be if we talk about the distribution, some distribution are discrete. Some distribution are continuous. So there are different kinds of random variables. Some variable are independent. Some variable may depend on some other variables. So we can build some relationship between the independent variable and the dependent variables. And sometimes we only have one variable into consideration, but sometimes we can have multiple variables. And the dependence of the data is very important, because without that, basically we cannot to do much. We cannot for all the samples we want them to be independent, so we can do some estimation. We can do some inference. In this class, we also talk about some interaction. Sometimes the two variables, they are not independent. There are some interaction. We also cover that. Here are some basic theories regarding the probability. So we know the random phenomenon, which means the some value, some variable we cannot control, and sometimes we can only see the final results, like the genetic or the yield. Sometimes the phenotype can be affected by different factors. There are some genetic factors, there are some environment factors, but in addition about that, there are still some random effect. And we talk about two types of random variables. Basically, that's the discrete and the continuous. And we talk about some common distributions on the discrete variable and on the continuous variable. In probability, we also talk about the distribution. What is the probability distribution? What is the mean? Even though it's a random number, but the mean sometimes is fixed, and the variance is also fixed. So these are also some important parameters. We always wanted to find out in the probability. And so as the random variable, we mean we cannot before we see the result, we don't exactly know what will come out. If we flip a coin, we don't know whether we'll see the head or see the tail. There are some other example. Today I bring some assume to the class. Do you know what's this? Anyway, it's a Chinese chess. Maybe if you stay here long enough, you can learn how to play this. There's a board. I think which is 19 by 19 square. So actually, this is the very popular sport in China.
Most of the old people they play.
You even the young people. Do some international contest on this. So let's say in this box, actually I put there are two colors, black and white. So when I come here, there are 3/4 of black and 1/4 of white. Of course, now let's say if I draw a random sample, well, it can be bad. I have just draw one. Actually, before I finish that, I don't know, whether I'm going to have the black and the white. But I know the probability. I know that I'll have more chance to pick up the black because the black, have more, than the white in this box. So let's say we basically, if I draw one chess, the distribution, it can be black, it can be white. That's a random number. That random number follow a distribution. The name of that distribution. If I only you draw one, you draw one. If we have a big class, we of course we somebody may have a white, somebody have black. So whether you will have the white or black follow a distribution. It's of course it's a statistic distribution. You know the name of that distribution? So what population do you know? Here I don't mean the biological population. I mean the statistical population. Or the population of random variables. So what population do you know? Nothing. That's the classification, continuous or discrete. Of course, this is discrete because we only have the outcome can only have two options. One is black and one is red. There's no other. This we call the we can count. Sometimes like the human head, basically, it can be any value from 100 centimeter to 200 centimeter, which is not we cannot count all the possible values. You take some basic statistical courses, no? So that population is called the 2-point. It's a 2-point distribution. Sometimes they also call the Bernoulli distribution, which can only have two outcomes. One we can call the if we have black, we can call them we succeed. If we don't have black, we say we may fail. So there are only two possible values of that random variable. So that's similar like here, but here if we flip a coin, the probability maybe it's a 0.5. No, but the probability for different cases can be different. In this box, we can say that if we have the black, we say succeed. That the probability is 3/4, which is 0.75. Here, it's like a coin, so we assume the coin is uniform. So the the probability to see the top or to see the tail is half and a half, right? That's the probability. So here the full proportion of the black in this box, actually that's the probability that we can have the black chess if we only draw one from this box. If we draw more, let's say if we draw 5, what's the if the number of black is a random number, so what's the possible values of that number? If we draw 5, anyway, of course you cannot see, when you draw from this box. Of course, if you draw 5, can you guess? Do you know how many black are you going to have in the 5 choices? Yeah, so maybe. So we cannot be 100% sure to have 4 or to have 3. But we know there are some possibility. So the probability to have 4 is higher than the probability to have 5. Do we agree? So if you say yes, you have a reason. Basically, we mean the probability to have all the possible values. We can know, if we have a distribution. So this distribution actually we call it a binomial distribution, and and the 5 is the number of choices we are going to draw. So the probability to have the black is 3 quarters. So in this distribution, if we know the x is the number of black, in the 5 samples. So this, what's the possible value? What's the possible value for this random number? Can it be 1? Can it be 0? Can it be 10? What's the possible value for this random variable? You said it can be 0? 0.5? How could you have you said half? How can you have a half black?
I mean, if you throw the white, then you are losing the black.
No, let's assume I have an infinite number of choices here. So it doesn't matter if you pick up one, I still have the proportion won't change. So how you can pick the half?
I mean,
just pick a fact. Don't do. First one, and pick up a fact. One fact.
Five.
You can take 5. One, you can take one. So what's the possible value for the random number?
It's 3.5, but then maybe we can take 3 or 4. We can get it's 3.5.
No, I mean, in one sample of a fact.
It is 1. If we pick 1, it will be black.
No, this is a discrete. It's impossible to have a half. Well, you cannot break my chest. So what's the possible all the possible values here? You can have 1, 2, and we have 2,
3, 4, 5.
3, 4, 5, 10. No. Yes. So these are all the possible values, and we know because there are, you know, probably we can guess if this is the probability of 4, the probability of 3, which probability is higher? No, I mean for this 2. 3 is higher. So you have a good guess. Why 3?
Because you have more black number.
For the 5, let's say if this, well, let's say we just the probability 5, then the probability 4, probability 3, probability 2, probability equal 1, probability equal 0. So you can guess for this 2, which one is higher? 5 is higher.
Probability 3.7.
How many people agree with the 5 have the highest probability? But there are some wet. There are also, 1/4 of wet. Okay, maybe let's see this 2. For this 2, which one is higher?
1.
1 is higher. So that's basically, we know something. Even though my point is, even for the random number, there's still some, rules to follow, or there are some trend. It doesn't mean the random number we cannot do anything about it. We can do something. We can do some prediction. So basically, if we know this this distribution, we know all the probability values. So I think I just go quickly here. Yeah. So for this like a distribution of discrete with the how to how to characterize the random number in probability. So basically in probability, if we know the probability for any possible value, we know everything about this distribution, or we know everything about the random number. And if we know this distribution, we can find any probability value we are interested. Let's say here we wanted to find the probability to to have at least one black and at least white. So this can be classified as at least one black and one white. You agree? Because here there's no black at all. Here there's no white at all. If we have either 1, 2, 3, 4, which means we have at least one black, at least one white. Understand? So if we have any number here, it means we have for the 5 chance. So if I ask what which possible values means there is at least one black and one white. At least we need one black and one white. So if we have one black, that means we have so let's say if this black number, of course, what's the number of white? What's the number of white? So if we have 0 black, means we have 5, everything is white. We have 4, we have 3, we have 2, we have 1, we have 0. So at least one black. These are at least one black. No? So these are at least one white. So that's why I said that these values actually represent if I ask you what's the probability to have at least the one white, at least the one black. Basically, you just add them up. You add them up, you have the probability. Understand? No. Well, it's terrible. Huh?
For which number do I make the add? Then the addition will be 8.
No, this is in total I have 5. So this is the sample size. So if we have no black, which means everything is white. If we have one black, there are 4 white. This is the two. This is the called the sample size. So these two variables, they are not really independent. So basically, the number of white is equal 12 minus b. So what's the then the probability for, if we know, the probability for any possible values, my point is we can find any probability we are interested. Let's see if I ask what's the probability to have to have at least before I said at least the one black, at least the one white. Now what's the probability to have at least the one black? At least the one black. So this at least this is the least the one. So these are the 5. If we consider add them up, it will give me that probability. So that's if I know the probability for any possible values, I can find any probability you ask. Agree?
So are we saying the probability of getting one black and the probability is 5?
No, I didn't say that. I didn't say, because these are the probability values we will find later. So now let's see if I know the probability to have to have any number of black, then I'm able to answer any question you ask. Let's say at least the one black and at least the one white, or just at least the one black, or at least the 2 black. So later we will in Excel, to in Excel their function, to tell us all the probability values. Maybe we just take a look. Take a look here. Let's see how I shift. Open it. Okay, here I read the number for black. So as you said, we know the distribution is binomial. So the sample size is 5, and the probability of in this box I have 3/4 of black. So this is the distribution for the number of black in 5 samples. And he also said that the sample size, the possible value is 1, 2, 3, 4, 5. and the probability is equal that could the binomial distribution, or binomial dot distribution is the same. And I put the number 12 is a 5. Probability is this. Here I put the 0. Anyway, I'm not very used to this computer. So it comes out. So basically, there's a function called the binomial distribution. So this is a function in Excel. It's to find any probability value for any binomial distribution. So in this distribution, you need to input, it's like the number of the value of the random variable, and how many experiments the sample set, and the proportion of black in the binomial distribution. And the 0 or 1 I will explain later. So if you press enter, it will give us this probability value. So basically, somebody said, to have 5 black, the probability to have 5 black is higher than 4, and that's not correct. So the probability to have 5, 4 is just 0.23, and the 4 actually, the 4 black is the largest probability. Anyway, so these are the probability actually should be written here. Maybe I will try again so you can follow. So you just input the normal binomial. So you just input a few letters, the sum of symbol will come out. So I think this is the latest version, 2007 Excel. If you have a lower version, you only see this function. Anyway, so we will use the latest version. Basically, in Excel, when you input the name of the function, the some parameters, will follow here. So you for this function you need to have four parameters here. So that's why when you use Excel you need to understand what does everyone mean here. So for this distribution, basically we have the three things we have seen here. So one is the sample size, another is the possible values, and another one is the p-value. So that are the first three here. So the first one actually is the number of possible values of the random number, because all the possible number is here. So later I wanted to draw, I wanted to I'll copy paste, and then you give a comma, and then we input a 5, which is the sample size written there, and then is the p-value is the 3/4. And in the end, there are two options whether you select true or false. So the difference is like this. If you have input false, it's just the probability for this value. If you input true, it means accumulated probability. So maybe let's try both so we can see the difference. I just input 1, and in another place I use false. So the same function. So the random number value is still 82. Sample size is still 5. P-value is 3/4. And if I change here from 0 to 1, so I don't see any difference, for the first one. But after that, I will see difference. So let's say you select 2 and you drag down. In Excel, you don't need to repeat everything. So you just make one cell and you drag it down. So immediately I have all the possible probability for the 6 possible values. And this probability, as I said, is accumulative. So which means this value is the for the probability for the value equal to 3 or below. This one is the probability for the value 4 or below 4. It's accumulated. Right? Basically, this one is the sum of these two. So this one is the sum of the first 3. This one is the sum of the first 4. So that's what we call accumulated. So now so the probability actually means given this distribution, because like you see before, if we know the distribution, we will know all the probabilities. So this actually we call it the probability distribution. We know through this distribution we can find any other distributions. That's the that's the probability. But for the probability cannot be, it can be 0, but it cannot be negative. We don't know if we have a negative. What does a negative probability mean? So all the probability is non-negative. And if we consider all the possible values, so the probability should be 1. Here, if I ask what's the probability to have the black chairs from 0 to 5, that's the probability 1. Because for any time, these are all the possible values we have considered. If we consider them all, the probability is equal to 1. No? So these are the the two requirements, for the probabilities. Any question?
How this of all the possibilities?
As I said here, so now if you can choose any 5 from that black. So if I ask what's the probability that you have the black chairs is from 0 to 5. That's all. There's no other possibility. So all the number of black, falls in this region. So that's by definition. If we consider all the possibilities, if we put them together, it must be 1.
Is it the same as when we say 100%?
Yeah, you can say probability 1 is 100%. What's the difference between 1 and 100%? For the probability, 100% is 1.
So this one is called accumulative distribution.
Yeah, this is like the accumulation. We add all the probability together. So this is the 2-point distribution or the Bernoulli distribution I mentioned at the very beginning. So it's just the probability, sometimes it can be 0.5, but sometimes it's not 0.5. So we assume the probability to be succeed is p. Of course, the probability to fail is 1 minus p, which is q. So these are the only 2 possible values. These are their probabilities. So this is the simplest distribution in statistics. Okay. So there's no distribution more simple than this one. There are only 2 possible values. Each one have a probability. So there are a lot actually the distribution like this. If you play game, every time you win, it's this kind of a distribution. Of course, the probability you win is very low. It's not 0.5. So the binomial distribution, actually, it comes from the Bernoulli distribution. So the Bernoulli distribution, basically, we only make 1 experiment. So if we, for the Bernoulli distribution, if we make a number of experiments, it's like here. So let's say you draw the 1 chair from this box. Of course, this is the Bernoulli distribution. If I draw 1, another 1, another 1, in total I draw 5. Then it becomes the binomial distribution. So for every sample, it still follows the Bernoulli distribution. But if we consider the 5 samples together, it's binomial distribution. It's written here. Well, you don't know any distribution before the class, so you are graduate students. Some of you may be PhD candidates. Huh? Then what do you know about the statistics or probability or mathematics? You know the number pi?
Yes.
You know the number e? Maybe this pi e I 1 0 1. You know this? You know the Euler equation? Or do you know any mathematician? Archimedes, you know? You know Euler? You know Gauss? Who do you know? Okay, so like this. So these are the 5 somebody called the golden numbers in mathematics. 0, 1, e, I, pi. What is I? Well, how you graduate from middle school? I don't say high school, middle school. Well, you can be excused like that, but there's still something we shouldn't forget. Well, if we learn something today and then we forget total everything after the class, then what are we going to do next class? Anyway, so now you know Bernoulli distribution. No? Don't forget. You know binomial distribution. Okay, at least you are making progress. You know 2 distributions. So the Bernoulli binomial distribution here is just the number sample is different. So I draw 10 samples. So these are the probability for the 11 possible values. So from this distribution, you can ask any probability. I can tell you. So you can ask the probability, to have the black number from 4 to 6. How we find that? What's the probability, to have 4 black to the black number from 4 to 6? Yeah, you just add them up. There's a form of 4 to 6. You just add the three probability together. So that's the probability. That's we can write it here. That's the probability. X is less or right. Yes. That's sometimes the question is not that easy. Let's say we ask what's the probability to get at least 2 black and then at least 2 white. What's the probability to at least the 2 black and at least the 2 white in the 10? How we find that probability? If I write the summation here, so at least the 2, so this is at least the 2, at least the 2 black, but also at least the 2 white. So it cannot be more than 8. If more than 8, I just have one white. So this actually is, to have at least 2 black, so here 2 white. So basically, you can add the probability from 2 to 8. You just add them up. That's the probability. So what's the probability to have the black chairs smaller than 2? Smaller than 2. That means you add, which means is 0, 1. I said smaller. I didn't say equal.
One and 9.
No, I just say at least the black number smaller than 2. I didn't say anything about white. The black number is less than 2. I didn't say anything else. So less than 2, what does this mean? So it means x equal to 1, or x equal 0 and 1. So if you add the probability for 0 and 1 there, that's the probability I asked. You can ask any probability. Ask one. Anyone. So let's say that that's a probability. Probability is we know a distribution, and then we want to find different actually in probability we call the invariance. We call the they select the invariance. Want to find this also an invariance. The probability of invariance for that to happen. No, we don't want to ask anything. Anyway. Okay, good.
If we have one white,
If we just read if you have one white, that's what you said. Okay. What's the probability to have exactly one white? Right?
yes.
So that means black is 9. Basically, that's the probability here is the probability you ask. Probability almost the 0. Well, there are many variables. The random, the value of the random variable is 9. The probability is very low. Okay, the previous. This one? Okay. So that's another distribution. Basically, the probability is 9 is here. So this 9 black, of course, is 1 white. So the reason we show you the probability, which means, when we have the talk about the statistics, once we have the samples, once we have the estimation, we want to do some inference. Then the inference basically is come back to probability again. So the significance level, the type 1 error, type 2 error. So that's all about the probability. So if we don't know how to find the probability, we don't know how to make a statistical inference. Once we have the sample, once we have the estimation. So you still remember, I think last week I said that what's the major contents in statistics? There are 3 words. Do you still remember? The 3 words in statistics. Sampling? Yes. There are only 3 words. Don't forget. Sampling, estimation, and test, or the inference. So that's everything about the statistics. There's no more than that. If you know the 3 words, you know everything about the statistics. Okay, so but there are some other distribution, discrete distribution. One is the Poisson distribution. So this also very happen, in the social society, in some bank, all the, you have some the number of guests, who visit, the supermarket. Basically, we can have the average number of customers, in a year, but every day the number of customers changes. So if we consider that a random number, so it's a Poisson distribution. Also the phone call. So how many phone calls do you receive every day on average? You receive 5 or 10, 2 or 3. So today, how many phone calls you receive? Okay, you see one. The tomorrow, do you know how many are you going to receive? You don't know. Yeah, maybe, yeah, you are right. That can happen. So this is exactly a Poisson distribution. So you said that you have received 2 on average. So the 2 is the lambda here. But every day, someday, well, if you are lucky, like me, I don't expect to receive any phone call, basically. If I'm lucky, it's a very quiet day. Sometimes you may receive 10. But if the average is 2, the probability to receive 10 is very low. But how low? So this distribution actually tell you. This exactly lambda equal to 2. So for those people who on average receive 2 phone calls every day, and then someday, if we consider many days, there are 14%. You wanted to see the percentage. So this is the percentage. Yeah, exactly. You can understand that is a percentage. There are 14% days you receive no phone call. There are 27 days you receive 1. Another 27 you receive 2. So you only have 1% of chance to receive 6, maybe or more. So with this probability, I can also ask many different probabilities. Like the probability has received a phone call number from 2 to 10, or I receive the phone call number more than 5, or less than 3, something like that. now you can you can have the probability. What's the probability to receive at least the 3 phone calls every day? At least the 3. At least 3, which means 0. Well, at least the 3. Well, if I said at most the 3, at most the 3, that's 0, 0, 1, 2, 3. So you add them together. So at least the 3, basically you need to add everything at the mark. Understand? Do you know? So this is some addition.